All right, let's get right into it. Today, we're not just studying theory, we are cracking open a real world, multi-million dollar case file. And this isn't just a story, it's going to give you the framework to absolutely ace your next exam. So let's dive in. So here's the big question at the heart of our case today. Let's rewind the clock. It's 2014, and Home Depot gets hit with a gigantic data breach. We're talking 56 million cardholders affected. But what if 8 years earlier, back in 2006, a cybersecurity vendor had walked in and said, hey, for $10 million, we can install a system to stop exactly this kind of thing from ever happening? Should they have said yes? That's what we're here to figure out. And just to understand the stakes, look at this number. $35 million. And get this, that was the direct cost that Home Depot had to pay after their insurance kicked in. This doesn't even touch on things like their stock price taking a hit or customers losing trust. It is a massive, painful number. So, how in the world do we answer our question? You might think, well, 10 million is less than 35 million. Easy. But not so fast. We're comparing money from 2006 to money from 2014. That's an 8-year gap. To do that right, we need a really fundamental concept in engineering economics. It's kind of like a time machine for money. And this is it, the time value of money. Our source material basically calls this the single most important idea in the entire field. It all boils down to one simple truth. Money you have right now is worth more than the exact same amount of money in the future. Why? Well, because you can put today's money to work. You can invest it, and it'll grow. Let's make this super simple. Imagine I offer you a choice, $100 today or $100 a year from now. If you take the money today, you can pop it in a savings account. Even with a simple 5% interest rate, in 1 year you'd have $105. But if you waited years to get that same $100 bill, you missed out on earning that extra $5. That lost opportunity, that is the time value of money in a nutshell. Okay, so to actually use this time value of money concept and solve our Home Depot mystery, we need to learn the lingo. And that really just means getting comfortable with a few key symbols. Think of these as the essential tools in our economic analysis toolkit. First up, we have P. P stands for present value, or present worth. This is basically any single chunk of money right now, at what we call time zero. It's our starting point. So in our case file, that $10 million investment proposed back in 2006, yep, that's our P. Next, you've got F for future value or future worth. If P is the starting line, F is the finish line. It's the single amount of money at some point down the road that's equivalent to our P-value today. So that $35 million loss that Home Depot suffered in 2014, that's a future amount. That's an F. And finally, we've got A. A stands for an annual series. Now this one's a little different. It's not a one-time thing. It's a string of payments that are all equal, and they happen at the end of consecutive periods, like every month or every year. The two magic words here are equal and consecutive. A car payment is a perfect example of an A series. So here's a quick cheat sheet of our toolkit. P is your money now. F is your money later. And A is a steady, repeating payment. And to make this whole thing work, we need two other key variables. I, which is our interest rate, and N, which is the number of periods, like years or months. All right, we have our case. We have our tools. Let's put them together and solve this thing. Our mission is to figure out, once and for all, if spending that $10 million back in '06 was a better move than taking a $35 million hit in '14. Okay, here's the play-by-play. Step one is just to lay out what we know. Our present value, P, is that $10 million. The number of periods, N, is 8 years. And the interest rate, I, which we'll use to represent inflation, is 4% per year. The unknown we're hunting for is the future value, F. So we use the magic of compound interest to push that $10 million forward in time. And when we run the numbers, that 2006 investment is equivalent to $13,686,000 in 2014 dollars. And this chart right here, it lays it all out. It makes the final answer so obvious. You can see the future value of that investment just under $14 million, sitting right next to the actual loss of $35 million. The difference is just huge. So the verdict is in, and it's a slam dunk. Looking at it from a purely economic perspective, using the time value of money, Home Depot absolutely should have made that $10 million investment. It would have saved them a ton of money in the long run. So we've cracked the case. Now let's zoom in on what really matters for you. what are the absolute must-know takeaways for your exam?
Okay, 4 key things. First, and most importantly, money has time value. $1 today is always worth more than $1 tomorrow. Second, P, F, and A. They are the ABCs of this field. You're going to use them constantly, so get to know them. Third, compound interest is the engine that makes all of this work. It's the tool that lets you make fair apples-to-apples comparisons across time. And finally, always remember the big picture. This isn't just about math. Engineering economics is a tool for making smarter decisions.
So I'll leave you with this final thought. We've been talking about Home Depot and millions of dollars, but this concept applies to everything. The money you decide to save, the career path you choose, even the time you spend studying for this exam today. Every one of those decisions has a present cost and a future value. So the real question is, what's the future value of the decisions you're making today?